everybody. I'm Arpana. I'm a customer engineer at Google Cloud, and today we're going to be talking about cloud native tech. The reason I think shouldn't be unclear, since the pandemic itself, it has accelerated the move to cloud. Earlier we were having, hardware, and that was very fixed. And with cloud, we could scale up and be flexible about our machinery, our servers. So that has changed. But has our way of building applications on cloud changed? Are we aware that has that changed? Has the practices, the ways of application development, have they changed? So today we're discussing the same with our panelists over here. Maybe we could start with, just discussing what and why cloud native even right now is so popular. Why are we moving to cloud native? Pradeep, maybe you could take that.
Very good evening, and I hope you guys are refreshed, and I'm one of the lucky ones to be with these youngsters over here. It is two things, it makes you nervous and it makes you excited, right? Because great thing to interact with the youngsters, you always get to learn something. So thank you, Arpana, Viktor, and Ilia to be part of this elite panelist, and thank you, DIGITALCONFEX, for having me over here. Very insightful sessions in the morning, and I will try to connect the cloud and why. I have an industry leader perspective, and then there is a technologist perspective over here, why and how perspective we are trying to do. We are in the era of digital economy, and this is the second wave of digital economy, and everybody is trying to encash the digital economy over here. What is happening is let's understand on the digital economy when we are telling there is a primary four things, critical components over there. It's called SMAC, right? Everybody must be aware of the social media, mobility, AI, and cloud, right? These are the four things which is pretty much driving. And in the recent phenomena, the IoT has got added over there. The smart and IoT is pretty much driving the digital economy over there. And then when we are looking into these aspects, there are three explosions happening. Everybody is aware about Moore's law, where the computing is actually getting doubled in every 18 months. Nowadays that time span has come down. And then look what is happening to the connectivity side. Just like between me and Ilia, we have established two persons having one connection, then when three people establishing two connections. And look how many possible connections is possible in this room itself. Think about the number of devices are getting connected. So explosion of the connectivity. So computing, connectivity, and the final piece is what's happening towards the bandwidth, which is making our data is very thing. So from industry perspective, if you will see that the imperative of cloud is driving digital economy in this current perspective. But when I'm coming down to the technologist view perspective, with all this growth and all those things happening, if you will see the business imperative coming over here is speed, agility, velocity, and scalability. That is what we were looking our speed at which we want our business to get the output out of it. The agility, the variety, or the differences about these things. And then the velocity, I will talk more of developer, applications developer velocity, because we would really, I will tell in several other IT companies, the product companies, maybe hardly 4 to 5 times in a year they were deploying. Now we are doing deployment in 10 to 15 days. Every 10 to 15 days we are trying, and that's the velocity impact we are talking over here. And if you will see the scalability, the amount of scale we are talking, and other explain these explosions happening and how do we scale. So the cloud comes basic very much to drive this tendency and be part of this digital transformation journey, or rather cloud is becoming a imperative for the digital transformation. It's driving digital transformations towards that. That would be my key takeaway or on the opening speech for that question of Anna.
Thanks, Pradeep. Can I have some thoughts from Ilia and Viktor as well? Like, what would you look at cloud native development from a developer perspective?
Again, hi everyone. My name is Viktor. Of course, very excited to be part of this panel discussion. So from cloud native, it means that you think about the application differently. You're not really tied to the hardware the application runs. You aim for decoupling of like what you're actually writing with where it actually runs. In terms of that, it should be like interchangeable. You should be able to experiment faster, to change things faster, to reason about your system in totally different, maybe automated way. So that's what I would understand by cloud native.
Thanks, Viktor. Maybe because Viktor, you mentioned decoupling, right? Can you talk a few ways about how can we decouple our applications or components of an application?
Yeah, I think decouple application is a new approach of new architecture of our microservices. Loosely coupled microservices, it's very important to deploy fast, to deploy with high quality, because you can, like for example, different developers merge into different branches, they have tests, so we can deploy super fast, because their changes, they are not depend on each other. So one developer can deploy its own changes, for example, adding a button to some web page, another developer can change something else, for example, backend. Since microservices is not connected, so this they are super loosely coupled, so you can deploy it at the same time. But here is one requirement: it should be covered by tests. So if it's not covered by tests, that means you could be in trouble.
When we talk about decoupling, I think we cannot skip containerization over here. Maybe one of you can talk about how can we manage the orchestration of containers. Now that you have decoupled applications, how do you manage these decoupled applications on cloud? Victor, you want to go ahead with
Maybe let's talk at first about containers itself, and then let's move to...
Please talk about it. Tell us about containers.
Yep, so containers in general aim to simplify things for the developers, for the operators. So if I try to define what container is, I would say that it's lightweight, deployable unit with its own runtime environment, which is almost independent of host operation system. Like I'm put here almost because 99% of the cases it is true. For 1% of the case, it might not be true. You still could have conflict because of that particular hardware. So if we break down this definition, we start from the lightweight. Lightweight, it means that running this container on a host system does not produce any significant or visible overhead. Of course, we are talking about cloud, serverless, but somewhere there still physical server. So it's not exactly like in clouds. So somewhere there is still physical server which should be paid for, which should be maintained, and the less burden, the less overhead we have, the better. Then we come to the point that it's deployable, right? Deployable means that once you have your container or image for container, you can move it between your development environment, production environment. That's why it's important, because generally you want to run the same software in, like, you want to test, you want to understand what have you developed, right? How does it behave? And then move the same to production. You don't want to have different environment in production and in dev, like whatever staging, how it depends how you call it, QA environment, because that's increase your maintenance costs. Like finding, fixing bugs, reproducing bugs, that's all pretty hard if you don't have parity with your environments. Then comes the question that we have cloud, we have different definition of cloud, like private, public, multi-cloud, hybrid cloud, etc. Once you have container, you can move, let's say, for cost experimentation, how much does it cost to run something on AWS, on GCK, on Azure. Let's say you run your private cloud, then you hit your scalability limits because you cannot order that fast your hardware, or real supply chain, physical supply chain. You want to quickly experiment, to quickly get some hardware from public cloud. You already have your containers, you just put them there, they run, all good. That's very important that you have deployable units. And again, we have separation of concerns. We decouple infrastructure. It's a different, slightly different decoupling way. Decouple infrastructure from application. And not in a way which we had before DevOps practice, when developers just hand over some application code to administrators and administrators just somehow run it, developers were not even aware. Not like this, but developers know that, okay, I produce artifact, I know that I run this container, I have access to this container in production, I can do it, but I'm not really concerned how exactly this container gets orchestrated. So that helps infrastructure team to focus on orchestration and developer focus on application. And then the last point of this container definition is separate environment. Not exactly like separate, but self-contained environment inside this container. It means that it's isolated, that I'm as organization or as application developer, I can develop one technology or let's say one version of particular language, library, then develop with another, don't be afraid of conflicts on my local machine, on my production server, etc. It's encapsulated and independent. And I believe a lot of people know about like dependency health in different technologies, either Python, Java, like C#, any, you name it, you will find the cases of incompatible libraries which are hard to maintain. Docker containers basically solve it. And of course it allows you experimentation. Again, experimentation is important because you want to move fast. You want to move fast, you want to try things. With isolation you can try different tech stack easily without worrying what should be done to set it up. You use one tech, you know that you spend that much on resources, you want to see whether another like new shiny tech optimizes it, you try in your separate container, you run it, it's fine. But the question how you exactly run it, how you do the orchestration, like ensuring high availability, scalability, that's another challenge which should be addressed separately. That's where I would like to give it back to Anna.
Thanks, Viktor. Thanks for letting our audience know about containerization. I think it couples very well with what Ilia said earlier about bringing in the speed with the separation of components in the application. Because if your components are separate and decoupled, then you are developing independently, and containers, I think, support that very well. Ilia, would you like to take on this question about how can you orchestrate these containers? What can be the tools or frameworks to handle them?
Sure. So usually for orchestrating containers, you have a special software called container orchestration tools. Unfortunately, we don't have much container orchestration anymore. I think we have only Apache Mesos. It's almost died already, it's almost deprecated. We have HashiCorp Nomad, it's still alive, and we still can see Docker Swarm in wild. And we have a big, huge thing, Kubernetes, and Kubernetes flavors. For example, OpenShift, Red Hat OpenShift, and Rancher.
And how can one get started with Kubernetes? Like if it's a tool that is very popular, how do I get started as a beginner in this field?
Well, I have two news. So one news is quite bad because Kubernetes is a big system, contains like a lot of different systems. But good thing is all the system is well known. So we already work with them. It's very fast, like 4 years already. So I would divide your journey in learning Kubernetes into paths. So first is refresh your knowledge. It's super nice to refresh your knowledge, for example, in Linux. So you should be familiar with terminal, with bash scripting. Next, Kubernetes is a distributed system. So it's like not only one host, you're running your workloads on multiple hosts. So it's vital to have good networking. So networking basics, routing, IP addresses, all these things is necessary. Another thing to know is containerization. You can start with Docker, like Docker exec, Docker run would be super nice. So this is about knowledge. Then you can start learning Kubernetes itself. So you can start with some Kubernetes basic, like for example, what is Kubernetes pod? What is Kubernetes deployment? when you you're familiar with YAML files, YAML format files, then you need to have Kubernetes to actually practice. So you can get Kubernetes, you can deploy it in AWS, for example, in Google, super fast and super cheap nowadays. And the last step, but super important, I think this is the most important step, it's practice. So you need to take your production workload, one of them, and try to move it to Kubernetes. So it could be super small, it could be super simple, but when you're moving your application from your private cloud to some Kubernetes workloads, you will face a lot of problems, you will face a lot of tasks to actually understand your Kubernetes environments. So I think it's the most important part.
And just to add, I was telling Gurmeet, I'm still using Mesos Marathon for some containers for your, these things you are telling me. It's dying, but yeah, I mean, we are still using.
Ilia, you mentioned that it can be challenging sometimes to move to Kubernetes. Then could you, maybe highlight what can be the ways to migrate our containers to a cloud application without having to, work with Kubernetes?
Yes. So there are a couple of tools which can help you in your Kubernetes journey. First of all, we can speak about things like Knative. So Knative is a framework. You're installing it onto Kubernetes, but it abstracts the Kubernetes layer from developers. So if you install Knative and configure it properly, so your developers don't need to understand Kubernetes at all. So they just create services, they create YAML files, and Knative automatically will convert their services in production and not production workloads. It will create networks, services, storage, and containers itself. This is first part. Another big thing, actually, it's coming nowadays. It's a concept of serverless. So in this all these container tools, you are operating on multiple nodes. So you need to configure these nodes, monitor these nodes, update these nodes. It's actually a lot of work. But nowadays, the new conception serverless means that you are not thinking about these nodes starting and deleting from a cluster automatically. So you just need some new resources, you're creating your workload, and if serverless application see that you need more resources, it automatically starts a new node. A good example of serverless is, for example, AWS Fargate. And for example, from my experience, when I started, maybe 10 years ago with Kubernetes, so we always use just normal nodes, bare metal, EC2 nodes. But nowadays, it's super easy to use AWS Fargate serverless because you don't need to manage your infrastructure, so it's super easy. And we don't need to hire new DevOps.
I think though that there can still be use cases where both Kubernetes, you need to use Kubernetes as a platform, but you also need to have serverless because you mentioned so many benefits of using serverless. Could you maybe help us a few points to judge between when to use what for the clarity of our audience here? How can we choose between, do I need a full Kubernetes platform or can I just go ahead with a serverless tool? Anyone can take.
Yep. So that's fairly hard question. That's highly depend on your application. So serverless, it's again, we still have physical server. So serverless usually fits into perspective when you have short Lambda, let's say Lambda task, when you have sort of fast running jobs which you fire based on events, and you just fire and wait for their completion. Kubernetes, that's rather a tool which allows you to manage your infrastructure. And pretty recently, I've read an interesting article from Spotify. So they used Kubernetes not in traditional way. So traditional, let's say if we don't have Kubernetes, we just have set of VMs, then we need some something to maintain like parity of the hardware. Let's say we provision new VM, we need to install all the dependency in there so it's ready, and then we can deploy something there. So we have certain tools to do it. So it's kind of like we have tools to do the preparation. Kubernetes is orchestration. What they did, they tried to still have a set of VM, set of fleet, and still maintain kind of like preparation tools, but use Kubernetes with its own extension points, which would allow them to see the real-time infrastructure they have. So Kubernetes, besides basic orchestration capabilities, has really rich extension points, and it allows you to create your custom resource definition, define how they should be managed, define your custom logic. So they used Kubernetes as a tool which kind of sits and observes their own set of virtual machines which runs independently. So that's not really a standard way of doing it, but still they're happy with it. So answering the question, not sure if I can answer it, highly depend on your task. If you need sophisticated orchestration platforms, then definitely Kubernetes is the way. It has certain burden costs. If you just have, I don't know, maybe some tasks, some jobs which you would run based on events, then sure, please go with serverless. And again, be mindful that your infrastructure requirement might change. You might be ready to adopt new technologies. You might be ready to move fast and change what you currently have.
To add one thing on that, on the serverless part, Viktor, this is a very right point. So what granular level we are coming about our functions to work, that is where the function as a service comes to your serverless world. I think if you can able to define your business requirement to that level, and it will become more independent and it will come to that kind of architecture. I think I agree, it is more a business imperative, what you are trying to look from that perspective, and how granular level you are actually defining your services. That is where this comes into the decision. This could be one decision, not only decisions will be there.
I think the summary I got from the conversation here is that when you require more granularity, when your application needs access to the underlying hardware, sometimes like the nodes on which Kubernetes is running, you may choose Kubernetes, like be on more of the side of Kubernetes. And when you want to hit your application, get started very quickly, then serverless could be the way, where you have functions or event-driven architecture, then serverless, more towards the serverless side of things. And when you need more granularity, more control, more custom logic, then Kubernetes-driven development. That's what I've understood. So we've talked about the current state of cloud-native architectures. I'd like to also know, what do you think about the future of cloud-native development? We have discussed AI and security in this forum today with great speakers from around the world. I'd like to know what you see as the future of cloud-native development in around, let's say, 5 years or 10 years. We could go around the panel with their thoughts on this.
Let me fix that on that basis, because I do not know how exactly in 5 to 10 years. But let's look what's currently happening from a cloud, different changes. We started with a public cloud. We started with a private cloud, went to public cloud, and now with the edge computing coming into picture, we are very much getting into multiple cloud and hybrid cloud. And I think the experts are there. They can actually throw lights on how technology is also shaping on to actually prepare our applications to move into this modern way of clouds over there. One other thing which is in future, this cloud adoption is going to be decided is the cost factor, which was not very relevant or not very known, not relevant was the wrong word, not very known earlier, but now cost in the cloud is also getting discussed because as several organizations started utilizing this, always the cost comes into these pictures over there. One thing for sure, it is actually getting us ready for our AI ML journey for the future, and that is going to kickstart over there. But I would like Viktor or Ilia to mention more about how, from an applications development perspective, it is shaping, or what is the orchestrations perspective we can expect.
Yes. So talking about application development and future of cloud, recently we observed already a trend that, let's say 5 years ago, how the development is done. You have your local machine, your local computer, laptop.
20 years back, I was doing development.
Do you miss it?
I don't know. That's one thing, and that's what few of the things we are discussing, that how we were bringing the whole monoliths or the legacy applications into applications, and I were kind of thinking, why we are not going and really redesigning or re-architecting it into microservices, bringing in. My thought process is, as you were telling, that as we were, developing this with these things, my journey, I was doing this as on a physical server, then after a decade we moved to virtual machines, and after a decade there is no machines, right? That is how the development has moved together.
Yes.
But I'm sorry to disturb you.
Yeah, that's kind of nostalgia. So yes, now application development, let's say especially for teams who are working with multiple applications, multiple text stacks, we have dev containers from Microsoft, from VS Code, where you can easily spin up Docker container on your laptop, and then work inside, like modify code with all the graphic interface of your favorite code editor, modify this code inside this dev container, and it's really handy. You don't think about installing additional dependencies, you don't think about installing some other, like, I don't know, languages, tools, make your laptop dirty, then you have to clean it. No, you just work inside container, and it simplifies your development process. It highly simplifies your development process. The next step is to move this container somewhere outside of your laptop. You basically don't need really powerful laptop to do development as a programmer, let's say. What you do, you just modify some text files, right? And then maybe you want to run locally your software which you just wrote, and for that you require like resources. You don't need to do it in your local, you can do it remotely. And now we see a movement for remote development. Like GitHub already provides this Gitpod, GitLab as well, where on demand you spin up some like container which has your project inside, has dependency installed. Then you modify, you run it, you see all the problems, you are able to access debugger, and then organization can save costs on the maintenance of kind of powerful laptops for the employees, costs on purchasing those powerful laptops. So it's all great. In future, I don't know, maybe we will move even to just to the browser. Like when I guess GitHub already exposed VS Code for browser, right? So you just have only one application on your laptop. Your laptop is super like simple, super, I don't know, cheap, and then you can do development. You can run your application with all the innovation in AI. Partially, your application can be written without you. You just verify that that's what I expected. Let's ship it to production. That's good. So that's maybe all from my side about the future of development.
Ilia, would you like to add anything on this?
Yeah, sure.
For the future.
I can tell about my observation. So back in the days, I was working as a head of DevOps in Spanish bank, and we had to implement Kubernetes our environment, and it was super hard because we needed to write a lot of scripts. So it was a lot of manual work, and it was really tired. Nowadays, if you're installing Kubernetes, it's almost out of a box. So one example, if you like want monitoring, you before and now you're installing like Prometheus. Before you had to configure with Prometheus from like everything. So you needed to configure alerts, you need to configure rules. Nowadays you're just installing a Prometheus operator, and in Prometheus operator you're just describing what do you want to achieve. So for example, I want to get metrics from this service, and that's it. This Prometheus operator will automatically configure your Prometheus, and you will get everything like metrics, alerts. So it's much easier. So first point, I think, like speaking about this containerization, it's like simplifying. So it's much simpler than before. Another thing I would speak about like Linux, for example, like 30 years ago. So we had Linux. To run Linux, you actually needed to run kernel, when you needed to some package manager, when you needed to install some daemons like SSH, NTP, and things like that. And it was like a pain because you had to configure a lot of things. Nowadays, you don't think about it as this one. You don't have conference about Linux kernels and things like that because everything pre-configured. You're just installing Ubuntu, Red Hat, and it works out of a box. So this is super cool. With Kubernetes, it's different. You have hundreds of conferences per year because nobody knows how to configure Kubernetes. So from my perspective, Kubernetes now in the era of like early Unix and Linux. So it has a lot of different parts, moving parts. It's a platform, but it still needs to mature. After that, it will be like a platform, and on this platform, we will just deploy our like layers, and it will automatically like add servers, add capacity, add storages, add resources. So from my perspective, Kubernetes future is super bright.
Maybe to it that maybe in future majority of developers won't be even that much aware of Kubernetes, just maybe some technical term that exists, let's say like hypervisor currently. Just they think like, okay, I have it somewhere, but I don't really interact with it anyhow.
Or developer might be doing something else other than development. Yeah.
That's definitely a possibility. I think the summary we got from here is that cloud native applications and both architectures are kind of like living systems, and they're going to change and evolve as time changes. 30 years ago, like Ilia was mentioning, it was so hard to get into the kernel of a machine remotely, and now we are talking serverless, where servers are there, but you're just not interacting with them because there's an abstraction layer in between. So basically simplifying things from the developers end. Cloud is just the tooling, and what you are having is a tool that makes it easy for you to develop, to build on your ideas and to build apps and get them to reality. Like Pradeep mentioned, maybe code would not be the medium to get to ideas and get them to reality, but there's definitely a layer of abstraction in between, and things are running on cloud itself. All of these Gen AI workloads or the security workloads. Now most of the new Gen AI workloads are, moving to cloud itself. They're born into cloud. And now when we think of security as well, the first thing that comes into mind is, what is the security around my cloud perimeter? And if I have a hybrid infrastructure, like something in my private cloud or a data center and something on cloud, then how do I secure this whole interaction, this whole networking? So I think moving forward, we're going to be looking more at the security and the networking and the development on a cloud native environment itself. So I think that's a skill to learn, and I'd like to close with this thought itself. Thank you. We are open to any questions now.
Have any questions here? All right, I'm coming on. So we'll start from here. Sir.
The beauty of developers group, they always deliver before time.
Yeah. What do you think about DCOS?
Come again?
What do you think about DCOS, Distributed Compute Operating System?
Distributed compute. Is it like particular implementation, or it's theoretical?
It's under the basically containerization, DCOS, modernization, distributed compute, DCOS.
I have never heard about it. What is it? It's based on
distributed computing operating system.
It's based on Linux.
Yeah, it is based on containerization Linux.
I'd like to share my thoughts here. Coming from Google, we have a platform called Anthos over here. So Anthos, the platform, what it does is, wherever your application container is sitting, whether it's on the edge or on cloud, you're able to manage it from one platform itself, and that platform is Anthos. It's a stack of products actually. It has container management, policy management, because if your containers are at the edge, then you do want the policies to be streamlined along these applications. So this is just one example, and because I am from Google Cloud, so I know of this product, but I'm sure that there are more products coming into this space because of the hybrid and the multi-cloud nature of cloud native development now coming in. So, yes, right. Exactly. I think he's talking about
I'm talking about distributed computing operating system. Basically, your operating system is distributed.
And what value does it provide when you have distributed operational system?
Sorry?
What value does it provide?
Actually, it is provide basically containerization. When you use containerization, your container is distributed to multiple infrastructure, not onto the one infrastructure.
So basically, my one container is deployed to
That is
multiple physical
related to
servers.
blockchain. You can imagine that your system is running on blockchain.
Might be.
too
I'm
much
not sure about that. And maybe Beaver is going there. The container on the bare metal could be there. The operating, the computing power for the container intelligently. Okay, that's good.
But that's again, it's not distributed operational system, right? No. That's distributed way how you deploy containers. That's not distributed operational system, as I understood it. I'm just sorry, but I don't understand the term distributed. Yeah. Deploying your workloads into multi-cloud environments, that makes sense. But your underlying, let's say, nodes,
Even
the actual
computing
hardware.
is distributed. Even your computing is distributed.
Yeah, computing can be distributed. That's fine. Let's say if you take Spark as data processing framework, it's distributed computing by nature. It is currently makes a great push into being able to deploy to Kubernetes. It's fairly successful. And yeah, that's exactly example of distributed computing when you deploy your workers as a containers into multiple physical servers. They each process different partition of your data and then come up with different results. Deploying, setting up, let's say, Kubernetes cluster between different clouds, that's as well possible with some network tricks. And that makes sense. Let's say you save on cost, you experiment. But as I understood from the term, distributed operational system, that's something, the same operational system unit which runs onto physical hosts? No, okay. So can you give the definitions then?
We will discuss further.
Okay, sure.
This is a more exploration topic. Thank you very
Okay.
much.
Can we have the next question, please, sir?
Yeah, hey, this is Ranjan. First of all, I would like to tell you that I could very well relate to your session. Just loved it. And I was feeling as if there's a YouTube tutorial going on, cloud and containerization, and you guys were fabulous.
Thank you.
That's a comment. And I can very well relate your session with the AI because cloud nowadays provides everything as a service. So one doesn't have to be a PhD or a neural network specialist, but just needs to know the right service. Now my question is that, and I was finding this conversation very intelligent. From the user-friendly perspective and from the power perspective, what do you think, is Docker a better or Kubernetes better? I have no idea. I tried to install Docker on my system, just lost somewhere. So I wanted to resume that. That's why I'm asking.
Yeah, I think I can answer this one. So it's a bit different thing. So Docker is a way how you run your applications. So you pack in all your dependencies in one package, and you are running on some server. Kubernetes is a container orchestration system. So it actually orchestrates with Docker containers. So for example, you have like 2 servers, and you have like 2 services on each, one service on each server. And Kubernetes can, for example, something is happening with your service, for example, stopped or it's panics, fault. So Kubernetes will be ensure that your service will start or restart. So it's a task of Kubernetes to actually orchestrate these containers. Docker can work only one host. So we have Docker Swarm, but Swarm is already almost dead. So Kubernetes, first, like the main thing with Kubernetes is to orchestrate your workloads, so your containers. It's not about Docker itself, because we have our containers. We have, for example, CRIO from Red Hat, but the idea is the same. So you're running some containers, Docker, CRIO, something like that, and Kubernetes is trying to achieve, for example, you want free processors for your service anywhere. You don't care about this one. You have 5 servers, you want just free processors. And Kubernetes run this server, this server, this server. How it runs? It can see that this node has, for example, 2 gigabytes of RAM and 2 CPU. This one, for example, has 3 gigabytes, this 4 gigabytes. And your service, it requires 3 gigabytes. So it will place your service on this node where it has 4 gigabytes. So it's like kind of clever thing. So this is basic things, and over that it can like connect storages, configure networking, and all these things.
Got it, thank you. Seems the tutorial is still on. Thank you.
Yeah, back in 2016, it was a challenge to configure, databases, especially on the Kubernetes platform. The reason being that databases are always stateful, right? That challenge has been long addressed. Now, in the last 7 years, with the advent of big data, a lot of new platforms got sprung up. And what we're talking about is mostly distributed databases and distributed relational databases and distributed in-memory databases. Now take an example of Google Spanner. If we have to deploy something, and we're talking about relational, I'm not talking about the NoSQL database systems because they have a different way of working. If we need to configure a distributed, relational database which has a shared nothing architecture, what do you see, from your experience that in terms of deployment of such systems on a Kubernetes platform, at this point in time, is it seamless, or are there still any challenges with distributed databases?
Yeah, I can answer. It's super seamless nowadays because we have special things in Kubernetes. It's a bit advanced topics. It's operator. So operator, it controls your application. So for example, you want to deploy Cassandra or MongoDB, so you're just creating an object in Kubernetes, for example, Cassandra cluster. You specify a number of replicas, for example, 3, and this operator, it will configure the whole cluster for you. So it will configure masters, slaves, it will put your Cassandras to different hosts, and will attach a disk to this one.
Yeah, that's a good point. But Cassandra again is a NoSQL system, and there is like a latency factor, right? And when you have a latency factor in a NoSQL platform like Cassandra, the log management works differently, especially because everything, the appending on the log, I do understand that with Cassandra the appends are very super fast, but the changes, any updates to the system are not that frequent. Now if such a thing were to happen with the relational form, do you think that it's similar in terms of the working? Are there no challenges with any relational platforms which are?
Yeah, you're right. So before migrating any stateful application to Kubernetes, you need to think, because Kubernetes brings a bit of latency because of networking, because of like some overhead. So you need to think, is like if you have really high loads, so maybe you need to test, for example, to try to deploy to normal servers, configure everything manually, or with Ansible, for example, and try with Kubernetes. Kubernetes, for example, we have like Sept, it's like storage, distributed storage, and it works great with Kubernetes. You're just installing the Sept, rook Sept, and it works. But for like Postgres, for example, the loads which require really high like network bandwidth, disk, CPU, so maybe you need to test before. You shouldn't like move everything to Kubernetes because it's Kubernetes, because it brings something like some additional configuration, some additional like Linux interaction, like IP tables, some of those things, so it will be a bit slower.
Yeah, I know we are running out of time. I have faced a similar problem in my transitions over here from OLTP, OLAP, and then document DBs when I were coming. I would love to share in the outside, but I know we are out of time.
Absolutely. So we can take that offline.
Maybe
Viktor
one
wants to say something.
one last point. So the operator pattern, which Ilia mentioned, basically vendors of database, they are interested in this new movement to Kubernetes. They're interested into making people run their software seamlessly in their Kubernetes cluster. So that's kind of like their responsibility to provide this operator. Surely there are challenges because how Kubernetes works, right? You don't have single server, but usually those challenges partially solved by vendors because they provide the actual artifact, the actual code base for this operator. And Kubernetes as well has certain primitives like node affinity, tolerations, which would allow them to create this operator with awareness when better to deploy, when better to do some maintenance, when to do like fallback from master to another like slave, etc. So there is complications, but usually these complications are taken care of by vendors themselves, who are the best knowledgeable people about their own databases. So, and to understand whether it fits for you, of course, you need to do some experimentation, you need to do some benchmarking, some test deployment. Yeah.
Thank you,
or just
Viktor, for your
discuss with
thoughts.
Pradeep. That also works.
Thank you, Viktor, for your thoughts. And I think they have really enjoyed this session because you can judge from the questions which are coming to you. So thank you very much for your insights.
So a big round of applause for them.
And I request the panelists to be present on the stage because we are going to have a felicitation ceremony.
So first of all, can we have a group photograph all together? So our camera people.
Request Mithali to be present on the stage, please. So certificate for the young lady present here, Arpana Mehta. Thanks for being here. Congratulations. Can we have a big round of applause? Next we have Viktor Sobol. Pradeep Kumar Mishra. Next we have Ilia with us.